Advanced Financial Modeling, Topic 2, Section 4, Compute and Graph Moving Average Volatility. Now, standard deviations, which are often called just simply volatility in finance, changes over time. It's often useful to see how standard deviations do change over time. The end-day moving average volatility graphs allow us to see how those standard deviations change over time. In our next worksheet, we're going to work on that same start file we've worked on in sections 1, 2, and 3 of topic 2. We're going to calculate a 20-day moving average volatility for SPY. And what we're going to do is we're going to calculate the 20-day moving average volatility. That would be the annualized standard deviation. That should be an A right there. The annualized standard deviation for the last 20 periods returns. And I'm going to annualize it by multiplying times the square root of 252 to annualize it, since again these are daily observations. And then I'm going to graph this to show how volatilities have changed over time. So going to our start file we've been working on for the last in this topic 2, sections 1, 2, and 3. I'm going to go to my SPY, and what I have here is new data. March 1st, 2019, then February 28th, 2019. So it's daily prices of the SPY. That's the S&P 500 ETF. And it goes down to 2014. I've already calculated the daily returns. Now what I'm going to do is I'm going to calculate the annualized standard deviation. So I'm going to equals STDEVP. Again, for this lecture, we're just going to use annualized standard deviations. I'm going to go down and get the trailing 20 days. So notice on the bottom of my screen there, it says 20 rows by one column. I'll then close that. That is what the daily standard deviation has been for the last 20 days. Now again, I always say that I'm going to annualize standard deviations. So I'm going to take that daily standard deviation and multiply times the square root of 252. And I get 786. So just the last 20 days, which is about 1 month, a little less than 1 month in trading days, the standard deviation for SPY has been 7.86%. If I copy that down, notice I have it so it stops 20 days from the bottom. You got to make sure you don't keep on having this formula continue, otherwise it starts using data that's missing and you get really low volatilities. And what I see is each one of these days is a sample of 20 prior days of returns, and then it calculates the standard deviation and annualizes it. Now notice I also have the standard deviation formula here. The full sample standard deviation over this period of time, March 2014 to March 2019, the full sample volatility is not 13.25% annualized. However, for the last month, it's been running only 786. Now I like to graph this right here, so I'm going to Control Shift down, grab all the data, select all the data. I'm going to slide it back up to the top. While the data is still selected, I'm going to insert a line graph. And what I see here is every point on this graph is showing me the 20 days prior. So the average standard deviation has been about 13%. However, it's been as high as 35 and as low as looks like around 3%. Now I like to put dates down here. Let me show you how to do that. I'm going to click on the data. You can see how it highlighted. Right click, select data. Where it says horizontal axis, I'm going to edit it. And I'm going to put in my dates, Control Shift down. However, I need to have it stop at 1242 as my last observation. 1242. Okay. And I'm going to go back up to the top and see if my dates are in. And there we go. From 2014 to 2018, the 20-day trailing or moving average volatility, it's been as high as 32 or so, and as low as about 4. So in this topic, we just talked about calculating moving average volatility. Now the big question for the next topic is, what do I think it's going to be next month? Is it going to be average, close to 13? Is it going to be what it's been running lately, say 7? So we're going to talk about a topic called exponentially weighted moving average volatility.